Welcome to another episode of Terry's Notes, and today we are going to be looking at electrolysis calculations. The first thing we need to understand is what is electric charge, and electric charge is simply equal to current multiplied by time. So Q is equal to I multiplied by T, where Q is charge and the unit of charge is the coulomb. I is current measured in amperes and time is measured in seconds. So we just need to remember that Q is equal to I multiplied by T. This is a very important formula that you will be using in electrolysis calculations. Now let's look at an example. A current of 2 amps flows through an electrolyte for 5 minutes. Calculate the charge transferred during electrolysis. Now, whenever they give you time in minutes or hours, we need to convert this time into seconds. So you need to remember that there are 60 seconds in 1 minute. Alright, so in this case, if we want to find the total charge flowing, we write Q is equal to IT. In this case, the current is 2.0 amps, and we need to convert the time into seconds. In this case, the time was 5 minutes, so we need to take 5 and multiply it by 60. Therefore, the total charge flowing will be 600 coulombs. Let's look at another example. Some lead-2 bromide is heated in a crucible until it is molten. So if you recall, lead-2 bromide is a solid, and in order for us to electrolyze it, so if we have PBr2, lead-2 bromide, we need to heat the solid so that it becomes molten, so that an electric current can flow through the circuit. Alright. Now, we have 2 carbon electrodes inserted in the crucible, and an electric current of 1.8 amps flows through the molten lead-2 bromide for 12 minutes. Calculate the mass of lead deposited at the cathode. Now, in all these questions, the first thing you need to do is to determine the charge that is flowing through the circuit. So we always started by writing Q is equal to IT. In this case, the current is 1.8 amps, and the time is given as 12 minutes. But as I said before, we need to convert the minutes into seconds. So this will be 12 multiplied by 60. Therefore, the total charge will be 1.8 multiplied by 12 multiplied by 60, which gives us 1296 coulombs. The next thing we need to do is to write the half equation for the reaction taking place. Now we are only interested in the lead in this case, and what will happen is that lead-2 ions plus 2 electrons produces lead. Now, let me just do this again. So we have the 2 carbon electrodes. Keep in mind that this is heat, it's molten. And so this is a positive terminal and this is a negative terminal. And inside the electrolyte we have Pb2 plus, and we also have Br minus. So remember, the positive electrode is called the anode and the negative electrode is called the cathode. In this case, the Pb2 plus will migrate towards the cathode. So therefore, Pb2 plus 2 electrons produces Pb solid. Now, what does this half equation tell us? Now you see this 2 in front of the electrons. That means that 2 Faradays are required to produce 1 mole of lead. Okay? The number in front of the lead here is 1. We don't write 1, but it is understood that there's a 1 here. So by looking at the equation, we can see 2 Faradays produces 1 mole of lead. Now, we know that 1 Faraday is equal to 96,500 coulombs. So if we have 2 Faradays, it'll be 2 multiplied by 96,500 coulombs of charge is required to produce 207 grams of lead. Now, where did I get this? Now, if we go back to the question, we see that the relative atomic mass of lead is 207, right? That is required because what that tells you is that 1 mole of lead has a mass of 207 grams. So we come back to the calculation. We have 2 multiplied by 96,500 coulombs of charge is required to produce 207 grams of lead. And previously we calculated the amount of charge flowing in the circuit, which was 1296 coulombs. So 1296 coulombs of charge is required to produce. Now remember, I told you when you write your statement in a particular way, it is pretty straightforward. So it is 1296 multiplied by 207 divided by, open brackets, 2 multiplied by 96,500 coulombs. Okay, and this gives us 1.39 grams of lead. Okay, so just to recap the steps, first thing we need to do is to calculate the amount of charge flowing in the circuit, and that is Q equal I multiplied by T. We needed to convert the 12 minutes into seconds. And once we do that, we need to write the half equation. And once we write the half equation, we can determine how many Faradays produces 1 mole of, in this case, is lead. And then we write up our normal mole calculation. Okay. Let's look at another example. Dilute sulfuric acid is electrolyzed using graphite electrodes. A current of 0.8 amps flows through the circuit through the solution for a period of 30 minutes. Calculate the volume of oxygen gas produced at the anode at room temperature and pressure. So they're going to give you certain pieces of information here. We need to pay attention to the current. It is 0.8 amps. The period is 30 minutes. So we can use that to calculate the charge. And they said the volume of oxygen gas produced at the anode at room temperature and pressure. So this is RTP. Alright, so they need to tell us about RTP. So we know the Faraday's constant is 96,500 coulombs. And 1 mole of a gas occupies 24 dm cube at RTP. So let's go to the calculation now. So okay, so in this case we work out the charge first, which is 0.8 multiplied by 30 multiplied by 60. Now remember, it's 30 minutes, so I needed to convert the 30 minutes into seconds, so that's why we have to multiply by 60. So therefore the total charge will be 1440 coulombs. The next step is to write the half equation. Now you see this equation, this is a very important equation that you need to commit to memory. 4 OH minus 4 electrons produces 2 H2O plus O2. In this case, we are dealing with dilute sulfuric acid. Alright, so the half equation will be the 4 OH minus 4 electrons produces 2 H2O plus O2. Now what does the equation tell us? Now you notice there's a 4 in front of here. Alright, so that tells us that 4 Faradays are required to produce, remember in front of this oxygen here there's a 1, that is, it is understood that it is a 1 there. So 4 Faradays are required to produce 1 mole of oxygen gas. Therefore, you know the 1 Faraday is equal to 96,500 coulombs. So therefore 4 multiplied by 96,500 coulombs produces 1 mole of gas is 24 dm cube or 24,000 cm cube of oxygen gas. Alright, this was given in the question. So 1 mole of a gas right, at RTP is 24 dm cube, and 24 dm cube is simply 24,000 cm cube. And we had worked out the charge as 1440 coulombs. Therefore 1440 coulombs produces, you have to cross multiply, so we need to take the 1440 multiply by 24,000 divided by open brackets 4 by 96,500. And when we work this out, we get 89.8 cm cube of oxygen gas. Let's look at a last example. We have a metal spoon that is being copper plated using copper 2 sulfate as the electrolyte. A current of 0.5 amp flows through the solution for a period of 2 hours. Calculate the mass of copper deposited on the spoon. And they gave us the Faraday's constant as 96,500 and the relative atomic mass of copper is 64. Now, the first thing we need to do is calculate the charge flowing through the circuit. They gave us the current as 0.5 amps and they said 2 hours. Now 2 hours, we need to convert the 2 hours into minutes and then the seconds. So it'll be 2 multiplied by 60 multiplied by another 60, right? Because 1 minute equals 60 seconds and 60 minutes is 1 hour, right? And we also need to write the half equation, which would be Cu2 plus 2 electrons producing copper. From this equation, it tells us that, look at it, we have a 2 in front of the electrons. So 2 Faradays are required to produce 1 mole of copper. The 1 is not written in front of the copper, but it is understood that there's a 1 here. So 2 multiplied by 96,500 coulombs produces 1 mole of copper, which is 64 grams of copper. Therefore, 3600 coulombs produces 3600 multiplied by 64 divided by open brackets 2 multiplied by 96,500, and this gives us 1.19 grams of copper. So just to recap the steps, the first thing we need to do in all these calculations is to find the amount of charge flowing through the circuit. Next, we write the half equation so we can determine the number of Faradays we are dealing with, and then we set up our statements to determine what is required in the question.